Hello, welcome to my channel again. Today we have Leetcode 132, just Palindrome partitioning 2. I previously done a video on the first part, which was mainly a backtracking question. So let's get into this one. It really has a short problem description. So here we are given a string S, partition S, such that every substring of S is a palindrome. Return the minimum number of cards needed for a palindrome partition of S. So basically, as the question demands, right, we want every substring to be S, and we want the version of the partitioning that gives um, at least number of cards, right, or the least number of partitions. Essentially, you can also have the question in that way. So how are we going to solve this problem, right? Well, you can think of this question recursively, right? Like if I solve each sub problem, right, then I'll be able to solve other sub problems. So, for example, your biggest sub problem is finding if a substring or a particular substring is a palindrome, right? But if it is a palindrome, then we are allowed to cut, right? And then essentially it's going to be that, like, okay, I cut here, I'm going to check for the other substrings and check the number of cuts that I make also, and the one that gives me the least number of cuts, right, is the one that I'm going to use. And not just with the recursion are we going to solve the problem, but we are also going to memorize our stuff. For example, let's say I know that for the substring AA, right, the least number of cuts I need is is zero, because AA is a palindrome. Let's say I know that, right? I can use that, build upon it, and use that to solve for the rest of the problem. So I know that, for example, if AA is a palindrome and I do not need to cut this palindrome, then if I'm cutting it here, I'm cutting B, I'm partitioning AB between A and so AAB between A and B here, right? Then my minimum number of cuts will be what, one, for example. So I just want to show you like how we are going to solve the problem. It's going to be in two parts. Mainly that we I was trying to pause the video, but mainly the two parts is that, like, we want to pre-compute if we have a palindrome in the first place, right? If a substring is a palindrome in the first place, and then use our memorization to essentially get the minimum number of partitions we use, and then from there we can get the number of cuts that we needed. Right. So I'm on the whiteboard now, and I have a snippet of our code. So basically, what we want to do is have for the is palindrome part an n by n matrix that's going to keep, for example, the it's actually going to keep the indices at which the two indices, right, the I and the j, are going to be two indices between which you have a palindrome. So for example, let's say I have AAB, right? And I'm just gonna make a quick table so that doesn't look so bad. But basically, you have index. Let's do zero index, right? So 0, 1, and 2, and then it's n by n, right? So 0, 1 here, and 2 here. Now we start at index 0 and 0, right? Is what we have is between 0 and 0. Is it a palindrome? Yes, is it right? A on its own is a palindrome. And such as index 0 and 1, right, is a palindrome, right? It is, so it's also true. And is B a palindrome? No, right? It's gonna check um, coming in with 2 pointers, right? Like A and B are actually not valid, so this is not palindrome, right? So we're gonna have false, and here will be false by default, right? Because we are not going to start at index 0, so we can't touch this part basically. So from index 1, right? So we have 1 and 1. Is there a palindrome? I have just this A. It is, so true, right? Same with the 1 to 2, right? So is AB a palindrome? No, it is not, right? And again, we have false here and false here because we cannot start from here. So from 2, right, 2 and 2, it's just be a palindrome. It is so true. So basically, this is how we refer to the table, right? And then that'll be able to give us that between index 0 and maybe index 1, we can have a palindrome, or and so on and so forth. You know what I mean? So basically, once we are able to compute this, then we'll do our DFS, right? We'll have a for loop, and we have a value we'll call min, right? So the min is going to be the minimum number of partitions that we've used, right? So when we find out that something is a palindrome, right, then it's possible we can use that palindrome, right? So we'll say 1 plus the DFS, right? And I'll show you the function later, but the DFS on the rest of the string, the rest of the string, basically, right? So if we find a substring that is a palindrome, right, then we check for the rest. Like, are we going to be able to hit the end and find other substrings of palindromes? If it's true, then that's a positive, right? If it's not, then that is what's you know that's a negative, basically. And then the part that gives us the minimum is what we will return. So basically, with our memorizations, we'll be keeping it in the DP array, right, and we'll be keeping the minimum number of partitions we've seen. So note that when you have a string A, right, and you divide here, right, you have AA and B on one side, right? There are two partitions, right? I have this side and this side. That's why I have plus one right here. Now, even though we have two partitions, right, we do have just one cut here. So the cut is the number of partitions minus one. So this is what we will return in the end. So without further ado, I just want to show the code and hold on. So basically, it's very simple to grasp. Now we have like discussed what we need to do. So we first want to keep the length of the string, right? We use that to build our DP matrix and 2D matrix that is keeping the indices for which we have a palindrome, right? So I want to call that matrix is palindrome, and then our DP basically is just DP. Initially, we want to fill our DP array with what -1, so that we know if we've changed it or not. Because in our memorization, we can easily return um, a sub problem that we've already done, right? And then use that. Um, but to be able to return one, right, we have to know that if we've actually even changed the DP array, that's why we fill it with -1s. And then if we've changed the right, then we just return. And also, so now for um, it's palindrome, right? We have two indices. We have I, and then we have J, right? So J starts from I, wherever I is, but J is on the other side. So think of it as I and J are two different pointers, right? So I is going inwards, right? It's increasing, and J is decreasing. So J will start at I, wherever I is, right? And then J is going to be greater or equal to 0, and then J minus 1. Basically, we are going to reduce. Now, how do we know we have a palindrome on our hands? Well, if the I and J are the same, right, then it's if the I and J are the same, right, the 2 pointers are the same. We want to check if what is in the middle is a palindrome or not, right? You know, so if I and J are the same, and let's say that the difference between I and J, right? So the amount of absolute value, it's this one possible case, right? Where the amount of absolute value between I and J is less than 2. And is it less than 2, meaning it's either a 0, right? There's nothing in between them. Like for and A, for example, let's say I and J was at A, wherever these, there's nothing in between them, right? So if the difference between them is what less than 0, less than 2, right, it's either there's nothing in between them or there's just a single character in between them. And if there's a single character in between them, it's a 566, because that single character in itself is a palindrome, right? So that's our problem. It's a palindrome, or it's either that, or we can say maybe it is greater in length, and what to check also then palindrome J plus 1, right, and I minus 1, which is basically keeping um the truth value of the of the substring in between what ing, right? Is what's between ing a palindrome, yes or no? If it is, right, let me change it here. So it's palindrome, right? If it is, right, then it will return true. Let me see if I have my brackets right. So yeah, cool. So if so, right, then it's palindrome of j, sorry, of the ai, right? Going to set that to true. Okay, cool. Now after that, what we want to do is to just return, right, a DFS. Because our DFS is, we are going to make it an int function where the DFS is going to take s, it's going to take its palindrome, right? It's very important. It's also going to take our DP array for the memorization, and it's also going to take our starting index, right? So our starting index will be 0, and wherever this returns, right, it's going to return the number of partitions we need. So number of partitions, which is n minus 1, as I previously discussed, will be the formula. This is why I have return DFS minus 1, right? So then our DFS is int method takes a string as uh, uh, in its palindrome, the DP array, and then the starting index also, right? And now, if our start is at the end of our string, right, we want to return 0. It's just standard function with these ints. Like if you are done completing, return 0, so that it doesn't go index out of bounds. If the start keeps increasing. Um, if not, we also want to check if we've previously even done the subproblem before. Like if, let's say, we are at working on the rest of the string and we are working on B, but we've previously done the substring of AA, sorry, right, AA in a previous iteration, and we know that is maybe there's no division here needed, right? We can always tap into that. But when we tap into that, we can ask ourselves if that index position has been changed in our DP array. If it has, then we want to return DP start for that's one answer problem. If not, then we want to keep our main. We have a main that we are using, right? Because we are looking at the minimum number of partitions in this function. So I create main initially, and then I'll start at k, right? And k is going to be starting at a start index, and k is going to be like something that like expands basically. Right. So what I want to check is if the index we have, right, the two indices we have, which is start and k, if these are indices and between which we can find a valid palindrome. If it is, right, if it is a palindrome, then what we want to do is work on the sub problems then, right? So we say int count, which is a variable that will keep count. 1, right? We've met one more partition, or we have one more possible partition, right? Because with a palindrome and then a DFS on the rest of the string basically. So as is palindrome, again DP, and the rest of it is going to be k plus 1, right? So now after it becomes k plus 1, I reckon on the rest of it. So whatever answer that gives us, right? We want to keep what's in a variable we'll call main, which I've previously declared, right? So main is main of the count. So we work on the sub problems. Eventually, the for loop terminates, right? And for the current index that we're on, right, which is DP start, we're gonna say start should be equal to our main, and then we'll return our DP start. Right. So this is a minimum. There's a sub problem basically, right? And it's going to go through. Um, it's going to go through the rest of the string. We passed the first 3 test cases, right? And then let's have it actually. Right. So it'll be 43% of people, right? And as I was previously saying, right, we are going to start every possible index and go and work on the rest of the string. But because of our memorization, right, the number of iterations we need is gonna substantially reduce, right? Okay. Now, what is the runtime of this algorithm? Well, obviously, you have an n square um, operation here, right? When we are checking and creating all the possible, palindromes and getting their indices where they start, and also here also, right? Because for every start, we are going to start there, and in the worst case scenario, we are also going to go to the rest of the string, which is being done here in the rest of the DFS function, right? So this is also O of n square operation. So in total, it's going to be O of n square. That's the runtime of the whole algorithm. I hope you guys, got something useful out of this video. I'll see you guys on the next one. Peace.